that have joined. I think so there will be some 40 people. So as you know, the mandate of this session, I won't say this is a course, but rather I'll tell this is a session because we'd be just meeting for like 2-3 sessions, if I'm not wrong, that too for some hours. I mean, 1 hour each. That's what the session would be, right? So I think you all probably know that means what the course expectations or let's say the objectives is, right? So you might be coming across because this PPT or let's say this file, maybe it might have been already sent to you people, or let's say prior, I mean, after this course is over, let's say this session is over, you might be getting the materials. So there are a lot many material there might be a lot many contents, or let's say there might be a lot many topics which might not be discussed. So the main aim is to just to give you a glimpse, or let's say just to give you a taste, right? So what we have been doing in the past and what we plan on doing in the coming days as well. So this course, this session as a whole, what we try to do is we try to brush up, or let's say we try to join all the happenings in the oil and gas industry. That's what we are doing. All right. So about PA, there's no need of any further introduction. You have been hearing about it, right? So they have been doing well in the past, and they shall definitely do so in the coming days as well. So this course is a part of, or let's say this session is a part of the what to say? It's a 3-month long diploma course as well. So about which if you are interested, you may inquire to the team of PEA as well. So we have all the sectors, or let's say we have all the modules that are covered in the oil and gas sector, right? So this is just a glimpse of it as well, like I said. So it all starts with the bridge course, or let's say the basic overview of the courses, right? Then we have the exploration part, where we have the hydrocarbon exploration techniques. Then we have geology as well, right? Which then moves on to the drilling operations. Then we have the well logging, or let's say the formation evaluation approaches as well. Then it goes on, it continues with production engineering, then goes on to reservoir engineering, then enhanced oil recovery, and then later on what we do is we try to conclude with the other branches of the oil and gas sector, which can be HSE, it can be the unconventional, it can be the digitalization, or let's say the digital oil field concepts that has been running along in the oil and gas industry, right? So like I said, so I'd be reiterating the same thing. So we just want to give you a glimpse of it, right? So we just want to brush up on whatever you might have acquired or whatever you might have realized in the past, right? So that is what we are doing in this 3-4 sessions, which is happening today and tomorrow as well. So all right. So yeah, if we move on to the detailed course, which is a time-consuming one, then definitely we would be having much more interactions. We'd be having a lot many case studies to deal with. We'd be having a lot many discussions as well. We might be, means we would be providing you with pre-recorded lectures of certain topic-specific lectures as well. So that is a mix of all the the real-time discussions and then pre-recorded lectures as well. So that is what is there in the other part of the main course, that is the 3-month long course that we have been doing so. So when we're talking about the oil and gas sector, we all know that means it's a combination, or let's say it's a confluence of many topics. Yes. So what we have is all the disciplines all together, all the expertise all together. So what they do is they bring in all their technicalities, and that is what is helping us to recover the oil, or let's say the gas even from the subsurface, right? So it's a teamwork, it's a multidisciplinary approach, which is helping us to achieve the goals, which is a recovery of oil and gas at the end of the day. And that is what the oil and gas industry is doing, and that is how it is able to flourish. So moving ahead, so definitely we have to realize how oil and gas have formed. Yes, how this hydrocarbons have taken the current form, or let's say how they have gone through certain changes, because of which we are utilizing, or let's say we are enjoying its benefits. So it dates back to a lot many years back, wherein we had sorry, wherein we had a lot many organisms that existed before. What happened was they faced extinction. They started, getting buried in certain places. Then after the burial, so what happened was they were subjected to certain changes, or let's say some transformations. Yes, and these transformations led to the chemical changes in the structures. Yes, altogether. And then what happened was gradually it started developing the process of the formation of hydrocarbons. Right. So here what we have is we have certain elements. So pressure is one, temperature is one, time is one, right? And along with it, the depth. So you might be getting, or let's say we might be hearing news that there are a lot many fossil findings as well, right? So this is also a part of the life that has existed in the beginning. All right. So many of you might have heard about this term called planktons. Yes, so planktons are still existing today. So this is nothing, which is let's say which is extinct. So planktons are the small, or let's say the microorganisms which are existing even today, and they serve as the base, or let's say they are the tiniest of the tiniest living organisms which can be observed in today's world. So this planktons, or let's say this planktonic organisms, so they are existing in the oceans, they are existing in the seas. So this serves as the source of nutrients for the sea life. So these images which you see, so these are the microscopic images. Yeah. So this is something which is under the lens of the microscopes. That means when we are zooming in, into a high magnifying scale, into a high resolution scale. So that's when we get to see the actual representation, or let's say the actual existence of the planktons. This is what happens. So today, planktons can be found in the oceans, like I said. It can be in the seas as well, right? So what happens was gradually when they accumulate, or let's say when they populate, so they start rising to the surface of the sea, or let's say the surface of the water. And at times, if suppose if you happen to visit the beaches, or means not the nature, mean not the normal tourist beaches, but let's say the cliffside areas wherein you have the seas touching the land, right? So in certain cases, you might be getting to see, you might be getting to observe, certain a reddish kind of tinge in the sea water, in the oceanic water. So those are the indications of existence of the planktons, right? So this is what we call it as a bloom, a planktonic bloom, or let's say dinoflagellate bloom as well. So what happens is since the planktons are also rich in nutrients, so this is what causes the change in the color, what you can see here, right? So the blue water along with it, we are having some red layers, yeah, so that is surrounded to a larger extent. So these are the existence, or let's say these are the evidences from which we can say, or let's say we can understand or realize that there are planktons that are there. And this planktons, what happens is once they start aging, because everything has a certain age, or let's say a certain period of existence, right? So what happens is when they start aging out, and then when they expire, or let's say when they die, they start depositing, or let's say they start settling down on the seabeds. So when they start settling down, and in the due course there is lot many accumulations, so what happens is there is sedimentation processes as well. So that means the small sediment grains, so they too start accumulating, they too start getting deposited alongside the dead planktonic remains, right? And altogether what happens is they start forming tiny sedimentary layers, right? So which undergoes organic changes, or let's say the structural changes, because of the conditions of temperature, pressure, and time. Now we have heard about aerobic changes and anaerobic changes, if I'm not wrong, right? So in the absence of air and in the presence of air, right? So that's when the changes occurs. So in case of the plankton, so if there is little or let's say very less oxygen in the water, then what happens is these animals or let's say these organisms won't be able to survive, right? And that's when the dead plants and or let's say the dead plants or let's say the animal planktonic organisms, they start accumulating, right? And when the accumulation is just such that it is having more than 5% of organic matter, so what happens is that part of the rock or let's say that part of the sedimentary rock or layer, we call it as a black shale. The distinguishing character of black shale is, we'll be having certain black lines or let's say black indication would be there. So that would be telling us that here, we have a good amount or let's say we have a richness of organic matters in it. So as this black shell means after the black shell has been formed, now what happens is it will be subjected to certain temperatures. So while being subjected to a particular temperature, then what happens is they might be expelling out or let's say they might be undergoing transformations. So when it is subjected to to a high temperature, then what happens is we start getting the first product, or let's say the fundamental base of the hydrocarbons, which we call it as the kerogen. So, but then again, one should not, confuse yourself with kerosene or kerogen, because kerogen is something different from that of kerogen. Right? So, as you can see, the name suggests itself. So, sorry. So, kerogen is KEROGEN, whereas kerosene is KEROSENE. Right? Kerosene is a product of the hydrocarbons, that is crude oil, whereas kerogen is the first building block of the hydrocarbons. Right? So further upon being subjected to certain temperature ranges, it is then the kerogen breaks into individual fragments, or let's say individual parts of oil and gas. That is something you have to keep in mind. Now, when this kerogen is subjected to around, let's say, 90 degrees Celsius, all right, or let's say some 100 degrees Celsius, so that is when it changes itself to a liquid state. Now, these temperature ranges are crucial. This is very much necessary to keep in mind, but because this is the main factor. This is the main factor. Why? Because if suppose, like you see, that means if suppose the temperature ranges goes beyond 150 degrees Celsius or let's say centigrade, then the kerogen which you have, so this will be changing itself into gas, right? So normally for the liquid hydrocarbons, the temperature is around like 90 to 120 degrees Celsius, or which we call it as the oil window as well. So if not 90, then it can be at least 120 as well. So that is what we call it as the oil window, right? And during the oil window, we have the liquid hydrocarbons, or let's say the liquid state of the kerogen that we are getting, right? Apart from this, if it extends or if it goes beyond 150 degrees Celsius, or let's say if it is around like 150, 120 degrees Celsius, right? So in that cases, hydrocarbons transforms itself into a gaseous phase, or let's say it's the gaseous hydrocarbons. So these two temperature ranges or these two temperature windows are very much crucial to keep in mind. Right? And the rock wherein this changes have occurred, so that is what we call it as source rock. So source rock is the one where we have the initiation, or let's say where the formation of oil and gas has taken place. That is what the source rock is. So source rock, I think you might be recalling, it is one of the components of the petroleum system, right? So in petroleum system, we have certain components, source rock being one of them. Then apart from it, what we are having is we have the reservoir rocks, right? Then apart from reservoir rocks, we have other components, like we have the migration that is happening, yes. And then we have the cap rocks and the troughs. All together, what happens is they form the petroleum system. Yeah. Now, Now, why do oil and gas does not stay in the source rocks? That is another question. Yes. So why do we need to have reservoir rocks? Now, the source rock where the hydrocarbons have formed. So what happens there is like does not have the it does not have the sufficient capacity. It does not have the sufficient volume to hold the oil and gas. That means if we talk more detail, or let's say if we talk in more technical aspects, so that means it is lacking some holding capacity. So that holding capacity is the porosity we are talking about, or let's say the pore volume. Now, since the source rock is not having a sufficient capacity to hold the rocks, so what happens is it is the hydrocarbon liquids, or let's say the fluids, they start looking for certain areas, or let's say certain spaces to travel. All right, so that's when the migration occurs, right? So migration is an important aspect. Why? Because only in that case, what would happen is like we would be having the accumulation of hydrocarbons in some other areas. Now, those areas would be having sufficient pore volume, or let's say sufficient pore spaces, where there would be accumulations of oil and gas, right? And those areas, or let's say those rocks, that is what we call it as the reservoir rocks, right? So the oil and gas would be migrating up, right, through the rocks. There would be migration happening. There would be, let's say, traveling, or let's say there would be fluidity in those oil and gas, right? And then what will happen is they will eventually get trapped within the reservoir rocks. So that is what is happening. Then now, where do we mostly find the hydrocarbons, or let's say where has mostly this transformation of the organic materials into kerosene and then eventually to oil and gases happen? So, like I said at the very beginning, so there are certain criteria, there are certain necessary requirements that should have been satisfied. Only then it is possible to get oil and gas, right? So in such a context, so what happened is the world means the deposits of oil and gas you shall be finding, or let's say the origin is mostly in those areas which were which were warm, right, and which were shallow in depths, right? That means where mostly the planktons bloom, right? But the bottom waters, or let's say where the planktons had bloomed, right? So there the oxygen content was a bit less. That is what we are seeking for. So that is why you see that we have only certain areas, we have only dedicated regions in this world. Yes, globally we are having only a few areas, or let's say very few countries who are having this opportunity, or let's say who are blessed with the deposits of oil and gas, right? So this is one of the things. But then again, what happened in the later stage was there was transformation, or let's say there was was just change in the tectonic plates, change in the position of the existing land masses, right? So that means previously they were existing somewhere else, and by now it has taken place, or let's say by now it is shifted to some other area, or let's say the area where it is currently static, right? It's not static, but it's moving momentarily. But then again, that is how the things have changed, or let's say the tables have turned. Now, talking about the history, so see, everything is a mystery to everyone until it is being discovered, until society understands its worth. Yes, until people starts realizing, or people starts utilizing it for a better cause, right? So oil and gas, it did exist from time immemorial. So it was even before Christ that crude oil was there, but on a larger scale, on an industrial scale, so it was discovered very late, right? So it was this very person who, by the name Abraham Gessner, so he was the one who first, indicated, or let's say who was the first person to realize the worth of the hydrocarbons, right? Why? Because he was the person who invented, or let's say who formulated the process of the distillation. So distillation we know, right? So distillation, what happens is, so it's a separation process, or let's say it's a filtering process, wherein you are having liquids, yes, mixed up in the same stock, but based upon the volatility, based upon the boiling point differences, we might be able to separate them, right? So this was the person who developed that concept, who developed that process, and it was only because of this particular process that the industrial use, or let's say the extensive use of hydrocarbons, which we see today, that is why it is possible, right? And post that, so there was a massive bloom, or let's say there was a global boom in the production of oil and gas, right? And it was in the United States, wherein the first extensive use of the hydrocarbons, or let's say the oil industry, where we can see the major oil and gas companies, starting their businesses, or let's say starting their journey in the oil and gas sector. And today they are one of the big giants in the oil and gas industry, right? Right. So if Gessner, formulated, or let's say developed the first if Gessner, formulated the process of separation, it was Edwin Drake who found out the first, who gave birth to the first oil well, right? So it was under his supervision, wherein, so there's a place called Pennsylvania in the United States. So that's where, the first oil well, or let's say the modern oil well, was drilled and oil was discovered, right? So these are the two people, these are the two personalities whom we should be giving the credit to, right? And once oil was discovered, right? So means by drilling processes, or let's say by digging processes, then what happened was we started seeing, a massive increase, a boom in the number of exploration activities, or let's say a boom in the drilling activities. That's what happened. So currently, this is the status of the global oil producers. So as you can see, the countries marked in various colors are having reserves of oil and gas in quantities ranging from minimal to maximum, right? So out of this, we know that means there are certain major producers of oil and gas. So Venezuela being one of them, right? Then we have Saudi Arabia as well. We have the almost we have the Middle Eastern countries. We have Iran, we have Iraq, then we have Qatar as well. We have UAE as well, right? So then we have certain North American countries, right? Then again, we have the United States. We have oil and gas in few of the provinces in Canada, right? So many of the countries, like I said, so ranging from a very minimal quantity to a good one. So that's where the ranges exist, right? So we are having the distribution of oil and gas. That's how it is happening. Uh, so I guess this particular image might give you a better view, right? But then again, the figures definitely have changed, because if I'm not wrong, so this particular value which you see, so this was way back in 2018 and 17, if I'm not wrong, right? So my suggestion would be, that means you kindly check it for yourself as well, so that you get to understand the current scenario. So let's say the latest reserves for the individual countries. But then again, it's not necessary, because time and again we get to hear about the countries, or let's say people's people talking about the reserves of oil and gas and the associated geopolitical incidents that's happening. Nice. So this particular image tells us how oil and gas is crucial to us, right? So the current, the recent incidents regarding the war between Ukraine and Russia have also told us lot many things, have made us realize about how oil and gas is crucial for us, right? So this particular this particular images, means this is they are showing us the certain pathways, right? So these pathways are the transportation pathways, which means through which oil and gas is being transported. All right. So, and oil from Middle East goes out all the way to the United States. It can be exported all the way towards China as well, India as well, right, towards South America as well. So, depending upon the relations the nations are having, so there's a good transportation that is going on. Right. Now, there is a certain organization by the name of Organization of Petroleum Exporting Countries, which we call it as the OPEC, right? So the OPEC countries are holding a majority share of the oil and gas, right? So they happen to regulate, or they happen to, influence the oil and gas trades mostly, right? So as you can see, that means the OPEC countries altogether, so they're contributing to some 81% of the global oil production, whereas only some 19 to 20% is what is being regulated by the non-OPEC countries. So countries having good relations with this particular nations, especially with the OPEC nations, so definitely they would be very much benefited, if at times there are certain shortcomings, so let's say there are certain crunch in the oil and gas reserves. So that's what happened with India and Russia. So although rest of the countries were they're not happy, they were disappointed, but yeah, since India and Russia had a very good bonding and relationship, I'll say, so that helped to get them oil at a very discounted price. So that is how the strategies, or let's say that is how the trade is being handled, or it is being ensured. This particular statistics, although it's a very historical one, since it is showing us about the statistics of 2014. This shows the imports that are being made by the particular countries, right? So that, which is in million barrels per day, right? So one can just imagine that how crucial or how important is oil and gas for the daily industrial activities, and if one nation needs to achieve industrial excellence, or let's say industrial development, so definitely import, or let's say the utilization of oil and gas has to be in some very high quantities, right? So the statistics might have changed a bit, in 2016, by the way, right? So you can see that means it was some 6 point, means it was China was leading the race, but in 2016, it was overtaken by United States, right? Then again, you see Japan was here, right, at the third, but then again in 2016, it was being overtaken by India, right? So this is what shows us that means how the global scenario changes from time to time, and what this might indicate, or let's say, and then again, repercussions are also there as well. Like we are also, contributing a destruction of environment. So that is another thing that, again, we won't be discussing here, however, right? So that completely becomes another topic for us, right? Now, accordingly, what you'll also see is, depending upon the presence, or depending upon the reserves of oil and gas, so what we'll have is that the price of the crude oil will also change, right? So those countries who might be exporting crude oil, so definitely they might, and in those areas the crude oil might be cheap. As you can see, that means Venezuela is one of the major producers, exporter. Iran is one, Saudi Arabia is one. Yeah. So then the North American nations. So in those countries, you have a very cheaper price of crude oil, or let's say the oil and gas products are very much cheap there. Whereas in countries where it is completely relying on the import, that is, it's a consumer nation, in that case, what will happen is the prices would be a bit high. So that is something again we should realize, right? Because a consumer nation is relying on the imports, yeah. So they're purchasing, they're purchasing oil and gas from the exporters, let's say from Venezuela, right? So in that case, definitely the price would be high. Yes. Whereas for Saudi Arabia, or let's say for Venezuela, in those cases, they are selling the product, right? Or let's say they're selling the oil and gas. So definitely it is the source itself. So the price of the crude oil will be definitely a bit competitive. It will be lesser than what the price might be in India. All right. Then now you see. because of the growing scenarios in terms of environment destructions and all the regulations being, being formed, or let's say all the frameworks being developed for climate change, or let's say climate protection. So what you see that there is, a dip in the conventional fuels. All right. So there is a certain dip in the conventional fuels, and this is giving rise to the non-conventional, let's say, the renewable fuel sources. All right. So that is another reason why the oil and gas sector is, is a bit struggling. Yeah. So nowadays, what we see is there are certain, specifications for all the jobs that are being listed in the oil and gas sector, right? There are shortages of job as well. So that is another thing to worry about. But then again, fuel prices are also going high, right? So a lot many complications are coming up. So if we start looking into those matters, so definitely you'll get to realize that it's a multidimensional issue, it's a multidimensional topic, right? So which should be studied. And then again, the conclusion comes as such that it's not possible to replace oil and gas at the end. So although we are making efforts to shift towards the renewables, or let's say towards hybrid vehicles, or let's say hybrid fuels, you say, right? But then again, we won't be able to completely, or let's say, totally remove oil from the energy context. So oil and gas sector would still be there, if not for 1,000 years, then at least for the 500 years, it will be definitely be there, right? So till then, definitely we are having, a good scope to develop, or let's say to contribute altogether in the oil and gas sector, right? So talking about the environmental issues, or let's say the environmental concerns. So what you see here is that because of the legislations as I was talking about, because of the various regulations we were talking about, so what's happening is, like, means we need to shift to a net zero scenario, wherein we will be having very less, or let's say completely zero carbon emissions. So in such cases, so you can see that means if we are to bring down the use of fossil fuels, so what the scenarios would be looking like there. So that means if you're bringing down the use of fossil fuels, then definitely the carbon emissions, which we consider it, or let's say which we quantified in terms of tons of CO2 emissions, right? So this is what the scenario looks like. Now, why 2050? Because majority of the nations have committed to achieve a net zero, an economy, or let's say a country, or let's say a society wherein there will be zero usage of carbon emitting fuel sources or energy sources. So that is the target year of 2050. So that is the reason why you see that 2050 is it's the net zero target that needs to be achieved. So by 2030, the countries have committed again. So that means they would be bringing it down by 50%. But then again, there are certain nations which have extended it. So which is extended to 2070. So that means that 50% reduction would be achieved at 2050, and it would be only in 2070 that they would be able to completely bring down on the use of carbon emitted energy sources. Now, the debate again remains whether renewable energy would be able to replace the conventional energies, right? So that means whether wind farms or whether solar energies, whether electric vehicles would be able to replace the ongoing energies of energy that has been provided by crude oil, or let's say the natural gases, right? So this is again a debate, right? So in certain cases where renewable energy gets the edge, right? So in the others, the conventional energy is definitely they're getting the edges, right? So if you talk about the cost of the electric vehicle, so for the time being, it's costlier than the conventional vehicles. But then again, if you are purchasing electric vehicle, then definitely you are contributing to very zero emissions. Yes, the maintenance costs are very less. Whereas for conventional fuel, the fuel prices are high, but then again the vehicle prices are low. right? Then again, the charging networks has to be again looked upon, right? So if you're running out of fuel, at least you can, go to a petrol pump, you can go to a fuel pump, and then you can refuel it. But for the EVs, you need to charge the vehicle for some time, right? You have to wait for it, and then only you can move ahead, right? So there are certain pros and cons in both the areas, so which needs to be, upon that. Then the second debate again, what it remains is that means what means in terms of energy, whether what amount of energy would be would the non-renewable the sorry the renewable energy sources would be able to provide us. Yes, because coal is a very good source of energy provider. Same goes with the hydrocarbons, right? So whether that particular benchmark would be satisfied, or let's say would be met by you know the renewable sources. Yes. So you know like the renewable sources are clean, no doubt, but then again they are not yet viable, they are not yet commercially viable as a fuel. So that is something which we have to keep in mind. Yeah. So with this, what we'll do is we'll start off with the happenings in the oil and gas industry in the next session, right? So if you have any questions to ask, you can put it up in the chat box, so which we'll try to happily resolve, right, as much as we can, right? So this is where I'd stop in for a time being, right? And then what we'll do is we'll start off with the domains of oil and gas in the next session. So the time, I think you will be already knowing it, right? So that is when we'll be starting with the coming discussions. So Nikhil, if you're there, so you can take up the session now, right?